graph traversals. Yeah. Before that, already we know what is a graph and the terminology of the graph, as well as representation of the graph. Can anyone tell how many ways we can represent the graph? Hello? Please tell me how many ways we can represent the graph, as we discussed in the last sessions. Hello, is it audible?
Yes, no, it's all.
Yeah, I'm asking how many ways we can represent a graph.
Three ways, sir.
What are those?
Adjacency matrix, sir. Adjacency list and incidence matrix.
Yeah, very good. So we can represent the graph in three ways. One is adjacency matrices and incidence matrices and adjacency list. So these are the three ways we can represent the graph. So the representation is very, very important for the graph. We know now what is a graph and what is a terminology and how to represent the graphs, correct? Yes or no?
Yes, sir.
Yeah. So now today we are going to learn graph traversals. The traversal is nothing but to move from one node to another node. So how we are going to search a particular node in a graph in a better way, because in a graph we can move here n number of times same node. That's why here there is a chance of repetition to visit same node again and again, because your graph there is a chance of loops. These are cycles otherwise. Yes or no? Yes or no?
Yes, sir.
For example, if you want to traverse from Secunderabad railway station to CMR Technical Campus, here once you are coming one by one, next after Secunderabad railway station, Boinpalli, next Suchitra, next maybe the Kompalli, next maybe the Karlakoya. Maybe when you came in this path, when you came to uh, uh, Kompally, then you have taken U-turn and again go back, and again you taken U-turn at Suchitra, again come back. Here we are rotating here. Then maybe there is a chance in a graph, because you can visit from any node to any node. That's why there is a chance of the cycles also. So that is the reason here when you are going to traverse in a graph, we need some mechanism. Here, especially the traversing in a graph is having two ways. One is depth first search, another one is the breadth first search. Today we are going to learn depth first search. So before discussing this traversal, first of all, we make sure that one important point, we make sure to note one important point. Here, every time we are going to traverse in a best way, along with that, once you have to visit any node, you never visit again the same node. Because once you visit Kompally, again you come back to Kompally. So you have to move next to node only, unvisited node only. Here already if you are visited, you don't visit again. But if you are visiting again means maybe there is a chance of the loop and you are wasting your time. So that is why here to avoid such problem, simple, you once visit one particular node, then you go to unvisited node only, no need to come back to visiting of the same node. So this is the first point you must be remember. So for that we need to implement a mechanism for traversal. Otherwise, if we use a general way to visit the nodes for finding one particular node or moving to the destination, now there is a lot of confusion and a lot of time waste, because we are traversing same node, visiting same node again and again. Here unnecessarily we are wasting the time for visiting of particular node. That is the reason. you put one important note, that is, once you have to visit one particular node, you no need to visit again. So this is basic idea before moving to or before jumping to our main concept of depth first search or maybe the breadth first. Both are depending on this point only, but different mechanisms. I will tell you. Now understood the prerequisite of this. Uh, so breadth-first search and depth-first search traversals. Clear?
Yes, sir. Yes, sir.
Yeah. So that point you must be remember. Very important. If you understood that point, the things are very easy. Now is the screen is visible?
Yes, sir.
Yeah. Just it is loading. That if you understood that point, then the traversing is very easy. And along with that, we must know stack and queue. You know what is a stack and what is a queue. So in depth first search, with help of stack, we are going to traverse. Depth first search, DFS. So with help of stack, we have to traverse. Can anyone tell what is a stack now? What is a stack? Data structure? Hello? What is that stack data structure? Is it
First in,
audible?
last out.
That's enough. Sure. You people are already attempted first minute examination. What is stack data structure? Hello? Today what
A
happened?
linear data structure where push and pop can be performed only in one end.
Okay, which is called as star. Correct?
Yes, sir.
That's why it is following which order? First in, last out, or
Last
last
in,
in,
first out.
first order. Okay, good. Now we have to use stack in a depth first search and queue in a breadth first search. Okay, today we are going to learn depth first search first concept. And before that, already I told you, graph traversal is a technique used for a searching vertex in a graph. The graph traversal is also used to decide the order of vertices is visited in the search process. A graph traversal finds the edges to be used in the search process without creating loop. This point is very, very important. I told you. That means using graph traversal, we visit all the vertices of the graph without getting into the looping path. Here, this is the main point we have to remember when we are going to apply traversal mechanism. Is it clear? Is it clear? Hello? The responses are required. What happened
Yes,
today?
sir. Yes, sir.
Yeah, respond. Why today you people are not responding? What is going on? Hello? You people are feeling today is the last day in this 2020. That's why you are taking any decision. Huh? Hello? If you don't speak, then I will end the session. Please don't waste my time. Don't check my patience. Now tell me, this point is clear, everyone?
Yes, sir.
Yes, sir, it is clear.
Yeah. Now for this traversal, we have two search mechanisms, depth first search and breadth first search. So this is very important. Today's class is very important. You can get almost 20 to 30 marks in your external examination. I'm telling very clearly, please follow and respond it. Okay. Now today we are going to discuss about the depth first search. So very important point. You must be remember this. Here DFS traverse of a graph produces a spanning tree. Here even DFS as well as BFS both are going to produce after applying of DFS or BFS. we will get a spanning tree. The spanning tree is not there in the syllabus, but we have to learn what is the meaning of spanning tree. Spanning tree is a graph without loops. Simple. Hello? You know the graph. Graph is having there is a chance of cycles, but when after applying of DFS of any graph, you will get one result. That is a resulted graph. That graph must be the spanning tree graph only. Then what is the spanning tree? The spanning tree is nothing but which is a graph without cycles or without loops. Clear?
Yes, sir.
Yes,
Clear?
sir.
Yes, sir.
Yeah. Sure. Yeah. For that, we use stack data. Already I told you, in this case, we have to use stack data structure. In BFS, we are going to use queue data structure. Already you know what is stack, what is queue. Okay, we have to use. Now that queue data structure, what is the size? The size of the stack is, maximum size of the stack is total number of vertices, but total number of nodes are existed in that particular graph. We have to consider size of the stack. In BFS, the total number of vertices we have to consider queue size, maximum queue size. Clear? Same story. If you know DFS very clearly, easily you can understand BFS. That is what my intention. I am comparing now. Now clear this?
Yes, sir.
So now when you are to perform depth first search in a given a graph, we need to follow this following 7 steps. Here this the steps are very easy. Here, don't worry. We have to by heart these 7 steps. Not required. Just I am going to tell you now. After performing of depth first search with example, these steps automatically you can remember. There is no point of things or because it is very easy. And the first point is when you want to perform DFS, the same. These 7 steps are there for DFS also. Only small modification. Procedure is almost same. 90% is same. The first one is define a stack of size total number of vertices in a graph. So what should we do first? We need to define a stack. What is the stack size? What is the stack size here?
Total number of vertices in the graph.
Yeah, total number of vertices in a graph. Very good. So the second step is select any vertex as starting point for traversal. Visit the vertex and push it into the stack. Means here, what is the second step? You are going to select any node or any vertex as a starting point because graph in a graph you can choose any node as a starter. That's why you can select any node as per your requirements. Yes or no? Is it clear?
Yes, sir.
Yeah. After selecting of that node, then you need to visit that node. And after visiting, you must push it into the stack. Now you have to push that node into the stack. Clear the second step? Then I am going to use these steps only. Please understand. Is it clear?
Yes, sir.
Yes, sir.
Yeah. Coming to the third step, visit any one of the non-visited adjacent nodes because after the start node, we have so many nodes are connected. Adjacent nodes are there. So out of all these three, for example, 3 adjacent nodes are there. Out of all these 3 adjacent nodes, we can visit any node which is unvisited. For example, out of three, two are already one is already visited, two are not visited. In that two, you need to select any node. That is also you have the choice. Are you clear? Are you clear? Hello?
Clear, sir.
Yeah, visit any one of the non-visited adjacent vertices of a vertex, which is at the top of stack, and push it onto the stack. Once you have to visit that node, then you have to push into the stack. So after visiting compulsory, we need to push it. Understand? Understand this?
Sir, can you repeat once again?
Yes, sir.
Yeah, third step is very simple. Here, once you have, after second step, once you have to visit the start node, then we need to check what are the adjacent nodes are there for that node. Clear? What are the adjacent nodes? You know what is the adjacency? Yeah. Now, after finding out of those adjacent nodes, we are going to choose any one of unvisited adjacent node. Already, if you are visited, no need to visit again. Okay. Out of the connected nodes, if any node is you are already visited, don't visit that node. You need to choose here any one of the unvisited adjacent vertices or node. Clear?
Yes, sir.
Yes, sir, clear.
So after visiting, again you push it into stack. Compulsory. This is mandatory. After visiting any unvisited node, you have to push. So like how we are pushed, same way you have to push it. Clear about this third step?
Yes, sir.
Yeah. Now coming to the fourth step, repeat step 3. So this step is very important. Repeat the step 3 until there is no new vertex to be visited from the vertex, which is at the top of the stack. Here simple. Here you have to repeat the third step continuously until there is no node to visit, because all nodes are already visited. So there is no node unvisited, no node for unvisited. Then we need to stop this processing of third step. So otherwise you need to execute this third step. Understand? Understand this fourth step?
Yes, sir.
Now coming to the fifth. So when there is no new vertex to visit, there is no new vertex to visit, then use backtracking and pop one vertex from the stack. Simple. The backtracking is nothing but to move back. So from where you came to that particular node, again move back to that node. So after moving back, then you need to pop the top of the stack. Understood this fifth step? Backtracking means we are going to move back to the previous vertex from current vertex. Clear?
Yes, sir.
Yes, sir.
Yeah. Now coming to the sixth step, repeat step 3, 4, and 5 until stack becomes empty. Now you need to perform these 3, 4, 5 continuously until unless the stack becomes empty. Once the stack is empty, the seventh step. Once the stack is empty, then here we are going to remove unused edges. So sometimes we are not visiting some edges because of this procedure. If those edges you remove it and you will get the final spanning tree. So that is a depth first search. Clear this? Clear these steps? Here with example you can understand more clearly. Don't worry, but at least you must understand this. 7 steps. Hello.
Yes, sir. Clear, sir.
Yeah. Now shall we go with example?
Yes,
Yes,
sir.
sir.
Yes, sir.
Here I am going to tell. Okay, generally we need to write in your examination step by step. Step 1, step 2, step 3. But you will get confusion. So from this graph only, I am going to explain here how to do this particular span entry. Are you clear? Are you
Yes, sir.
clear? Then I will share uh, whiteboard. Maybe this whiteboard you are downloading, or whatever I am sharing every day. You people are downloading this because it is going to help a lot. Some examples I am explaining on board, right? Jamboard. So that link is came into
Sir,
your
sir,
chat box.
we can't
Tell me.
download that, sir. Excuse me, sir.
Tell me, tell me.
We can't able to download that because we need a permission from that owner.
So I am myself only the owner. So
Because
how
I
can,
visited it 3 times, sir. Because I
but
visited
once
it,
you
I can't
please
able to.
You please request me. I will give the permission whenever you want. I am giving you people who are asking. I'm giving the permission.
Okay.
Some other people are asking. So some has came now. Vamsi Chaudhary. Vamsi Chaudhary is asking now. Is it right? Are you there, Vamsi Chaudhary?
Yes, sir.
Hello. Yeah, he is
Yes, sir.
asking now. He has came. Yeah, please. You do that. Then I will give the permission. Don't worry. Is it fine? Someone is asking me. Who is that guy? May I know your name? Hello.
Hello. Excuse me. Bhargav.
Bhargav Shankar. Yeah. I will give the permission. Don't worry. You please request me. Then I
Sir, it's
will
downloading,
share
sir,
the
without
things. Don't worry.
permission.
Yeah, I don't know. He's asking, but I don't know. Okay, right. Now just same graph I am taking here. Okay. So you can choose any graph. I have taken actually big graph, very big one, because for your understanding purpose I have taken D. Even parallelly, if possible, parallelly work in your notebook, because it is very easy and you will get full marks for this question, and moreover it is very important also. If possible, you practice parallelly, maybe it is very easily. Once we are going to practice, no need to practice again. That is the beauty of our data structures. But the practicing is very, very important. Only for reading, we cannot do that. Yeah. Now my graph is over. Now is it visible? My graph is visible now?
Yes, sir.
Yeah. Here one thing I am telling here, there is no same answer for everyone, because everyone they can take their own decisions, right? Are you clear? Someone will start from D, someone will start from B, someone will start from F. They can do anything. That's why don't expect all answers are same. Finally, we need to produce the spanning tree. That is the formula, but don't expect everyone will get same outcome. Understand what I am telling? Hello? Hello?
Yes, sir.
Yeah. Now, as per the steps, what is the first step? What is the first step? Tell me.
Stack size is equals to total number of vertices.
Yeah, you need to define a stack. So the stack size must be total number of
What is this?
vertices, means nodes. Correct. Right. Now the stack size is how many vertices are there in this graph?
7.
7. Then this stack size maximum, the stack size is 7 only. Now it is going to accept only maximum 7 elements. Okay, right. Very good. Now, what should we do? Second step. Tell me the second step. What is the second step?
Select the starting point.
Select the any node as a start node. Tell me which node we want to select. Your reply fast type is running. Tell me which node we need to select as a start node.
A.
Okay, you want to take A only start node. Okay, I have taken A as a start node. So then after selecting, you need to visit. Once you need to visit, what should we do? We need to push that node into the stack. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yeah. Then I push it. Then later we need to find third step. We need to find adjacent nodes. So what are the adjacent nodes for A now?
B, D, and E.
B and D.
B, D, and E. B, D, and E. Three nodes are there. Yes or no?
Yes, sir.
Yeah. Here, out of these three, you can visit any one of the unvisited node. And these three nodes are unvisited or not? You are visited
Yes,
any
sir.
node? B, E, D?
No.
No. If you know means
No,
you
sir.
can choose any node. You can choose any node. That is up to you. Some people will be some people, that's why I told you. Yes, all solutions are not same. Finally, you will reach, but all solutions are not same. Then tell me which node you want to visit. All are unvisited only. Then tell me which node you want to visit.
E.
D.
Okay. You want to visit E. Yes, I visited. For understanding purpose, I am taking these colors. Yes, I visited. Earlier, I visited A. Then I visited E. Okay, once I visit E, then what should I do?
Push into stack.
Uh, Push that node into the stack. Very good, nice. And after visiting this E node, again you need to check what are the adjacent nodes of E. What are the adjacent nodes of this E? Sorry?
B, C, D, F.
A, T, B, C, F. All these are adjacent nodes. Yes or no?
Yes, sir.
A, D, B, C, F. All these are adjacent nodes. Out of these adjacent nodes, say A already you are visited. Correct? Hello? Already you are visited A node, right?
Yes, sir.
Now, what are the unvisited nodes of this adjacent nodes of E?
B, C, D, F.
B, C, D, F. Here, out of these four, now you can visit any one. Tell me, which node you want to visit next?
D.
B. D.
Only tell me one. It is not possible to visit all the nodes at a time in a DFS.
D, sir.
D, sir.
Okay. You want to visit B. Yes. I visited B. So once I visit B, then you need to push into the stack. Clear?
Yes, sir.
Now B. So now again you need to check. So this is continuously executing until we cannot find the unvisited node. So that is unvisited adjacent node. That is why. So now B. Here what are the adjacent nodes now for B? What are the adjacent nodes for B?
A, E, C.
A, E, C. So out of this, what are the unvisited adjacent node?
C.
C, sir.
Then there is no alternate. You need to visit only C. Correct? Yes or no?
Yes, sir.
Yes, sir.
Now you are visited C. Then we need to push into stack this node. Clear?
Yes, sir.
Right. Now we are at C. Now tell me, sir, what are the adjacent nodes of C?
E, F, G.
E, F,
B, E, F, G.
B, F,
B, F, G. Out of this, what are the unvisited adjacent nodes?
F and
F.
G.
And G.
F and G. Then you have two choices. Then tell me which node you want to visit now?
F.
G.
Yes.
Yep, sir.
F, you want to visit F. Okay. Yes, I am moving to F. I visited F. Once you visit F, then you need to
Push.
push into the stack. Very good. Now check from F. So what are the adjacent nodes are there?
E and G. E, G, C.
E, G, C. Out of this, which is the unvisited node? Which is the unvisited adjacent node?
G.
G. G. Then you need to visit G now, correct? Yes or no?
Yes, sir.
Then you need to push into the stack after visiting. Clear?
Yes, sir.
Yes, sir.
Clear this?
Yes, sir.
Now we are at G. Now check the adjacent nodes. What are the adjacent nodes for G?
CF.
CF. Now, is there any unvisited adjacent node?
No.
No, sir.
No. If it is no, what should we do?
Backtracking.
Yeah, we need to apply backtracking mechanism. Please carefully observe. Here backtrack. Here backtrack means here you move to the back. Understand? Hello?
Yes, sir.
Yes, sir.
Means here what is the node? G we have. Then we need to the back to F. Means we need to back to F. Means you need to pop after backtracking. We need to pop the top of the stack. Correct?
Yes, sir.
Are you following?
Yes, sir.
Yeah. Now we are at F. Again check what are the adjacent nodes are there for F. What are the adjacent nodes of F?
EC.
EC, G also there. Yes
G.
or no?
G.
Out of these three, is there any unvisited adjacent node?
No.
No, sir.
Is there any unvisited adjacent node?
No,
No,
sir.
sir.
If it is no, what should we do?
Pop del.
Pop.
Means backtrack. Pop the top of the stack and backtrack. Means it moves to the C. Yes or no? After popping C is there, then you move to the C. That is the backtrack. Clear? Hello?
Yes, sir.
Yes,
Yeah.
sir.
Again, third step. Repeat 3, 4, 5 steps. Already I told you. Right. C. Now we are at C. Now check any unvisited adjacent node of C. Tell me, is there any unvisited adjacent node for C?
No, sir.
No.
No. If it is no, what should we do?
Pop
Backtrack.
and backtrack.
Up
Backtrack
and
and pop.
backtrack. Here C to B. Now C to B. We move to the B. Correct. Correct. Hello?
Yes,
I
sir.
mean running. Yeah, respond quickly. Now from B. Now is there any unvisited adjacent node now for B?
No, sir.
No. If it is no, what should we do?
Backtrack.
Backtrack and pop.
Yeah. Top and backtrack. In B to E. Now we move to the E. Correct.
Yes, sir.
Yes, sir.
For E, is there any unvisited adjacent node?
Yes, sir.
Yes,
Yes.
sir.
D is
Yes,
there.
sir.
What is
D.
that? What is that?
D.
D.
Here D. Then you need to visit. Are you clear? After visiting, you need to push the node. Yes or no?
Yes, sir.
Now we are at D. Now check. Is there any unvisited adjacent node?
No, sir.
No, sir.
Well, no. If it is no means, what should we do? If there is no any unvisited adjacent node, then what should we do? Hello?
Pop.
Pop the top of the element. Then later
Backtrack.
backtrack. Good. Now we are at E. Now from E, is there any unvisited node now?
No, sir.
Is there any unvisited node?
No,
No,
sir.
sir.
No. If it is no, then what should we do?
Backtrack.
Sure. Pop the top of the element, backtrack. Sure. Backtrack means from E. What is the backtrack? A. Understand?
Yes, sir.
A. Now we are at A. Now is there any unvisited adjacent node for A?
No, sir.
No, sir.
No. If it is no, pop the top of the stack and backtrack. Are you clear?
Yes, sir.
Now stack is empty. Yes or no?
Yes, sir.
Until stack is empty, you need to perform 3, 4, 5 steps. Yes, we are did that. Correct? Now stack is empty. Yes or no?
Yes, sir.
If the stack is empty, the last step is what should we do? What should we do? Seventh step. Hello?
Remove unused edges.
Remove unused edges. Then you will get the spanning tree. Then tell me what are the unused edges? Huh? Can anyone tell what are the unused edges?
A, B, H.
A, B. If edge is unused, then I am erasing this edge. Next.
CG.
Sorry?
CG.
CG. Yes, this is also unused. That is why I have taken colors. Okay, maybe you can understand what I did. Next.
A, D,
EF.
ADEF.
Tell me one.
AD.
EF.
AD and EF. Still anything is there?
No, EC.
Check.
EC.
EC is also there. We are not visited this edge, correct? Yes or no? Now,
Yes, sir.
this is a spanning tree. If you observe, because if you observe here, there is no any loop. Is there any loop? No loop, right? Is there any loop? No loop, right?
No loop, sir.
No, sir.
That's why it is a spanning tree and it is a DFS. Here we are going to visit every node only one time because there is no loop. So this is a depth first search traversal. We are visited all the nodes in a graph. At the same time, we are not visited more than one time for each node without any loop. So that's why this is a depth first search and the outcome is a spanning tree. Understood, everyone?
Yes, sir.
Understood, everyone?
Yes, sir. Sir.
Yes, sir.
Yeah. Now, but you need to write this answer step by step. Here, how I have written in this procedure like this. Is it visible? Screen is visible now. Screen is visible.
Yes, sir.
Yes, sir.
Like in your examination, you need to like. Screen is not visible. Hello.
It is visible, sir.
It's visible, sir.
Now you need to write like this. Now that for your understanding purpose, I have taken that, but that board. But when you are going to write examination, you need to write this stepwise. Okay. So next movement. Next. So you have taken. See this order. This order. Okay, like this. Backtracking. Yeah, because different people will get a different answer. Don't confuse, sir. You are explaining something, notes is something, and I am doing something. No, because we are going to choose any node as a start node, and we can visit any unvisited node at any time. So that's why here. Now here for this procedure, the spanning tree is like that. But when we solved, the spanning tree is like this. Don't confuse. This answer is different. This answer is different. But it is wrong. No, because the choosing of the node, the unvisited node, it is going to play a vital role. Finally, you will get the solution is depth first search only. Are you clear now?
Yes, sir.
Because in this example they have taken A, and the next unvisited node they have taken B. From B they have taken C. From C they have taken E. Here the order is different. If you take in other order, it will be different. If you take the starting node E, the movement is going to different. Means if you take maybe Khammam to Sema Technical Campus, maybe the connectivities are different. If you take the Warangal to Sema Technical, the nodes are different. Like that, different nodes we are taking to reach to the destination. Maybe the path is going to different. You don't think all paths are same depending on the situation. Are you clear? Understand the intention of this traversal.
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
please. This is very important in real time. Most of the real time applications are working on this. Already, Google Maps is the one of the best evergreen application on the graphs. So that's why please try to practice it in your home and work out. Yeah, anything is there, we will discuss in the next class. Clear?